Hi guys, in this video we're going to talk about the speed distance time relation. We've got some notes pages here that we're going to be working on filling out. There's a big blank spot here, so we're going to try and make sure that we fit all of this in. I've got like 3-4 separate things that I want to fit in here, so if you want to think about making sure that you have enough room for that, that's a good idea. Okay, so first we're going to start off with what is speed. All right, and most people would say that speed is how fast something is going, and that would be totally right, because speed is definitely how fast you're going. But a more technical definition is it is the rate at which distance is covered. Okay, that's the fancy science definition. So if you want to sound really smart, you can talk about how speed is the rate at which distance is covered. Okay. And so what we're doing, this is the next part here. When we hear the word rate in math class, we're talking about something, whatever the rate that we're talking about per some amount of time, okay? And also in math class, the word per means to divide, okay? So if I were to write out a formula, okay, some formulas here to find the speed of an object, I would say that it is the something divided by time. So speed, which we use a V for, V is speed, is something divided by time. And because it's the rate at which distance is covered, then distance goes on the top, okay? Now, at some point in time, you're probably going to be asked to find what is the distance that was covered. Okay, so the distance that is covered, we're just gonna do a little bit of algebra here. The t is on the bottom, so we're going to multiply it away so that the d can be by itself. So it will be the speed times the time. And at some point in time, you may be asked, what is the time it took? How long did it take something to happen? And so to get the time by itself, we would divide by the v. So it will be d divided by v. Okay, so these are your formulas that you can use. Some units that are useful. I think nearly all of the ones in the practice sheet are using meters and seconds and meters per second. So v, which is the speed, will be measured in meters per second. D, which is the distance, is generally measured in meters, but as long as these two distances matter, that's all that needs to be true, okay? And T is for time, and time is measured generally in seconds, which we abbreviate with an S, not an SEC. As long as the time units match, it doesn't really matter. So we'll have to make sure that we check for that while we're working through problems, but we can totally do that, okay? So one more thing I want to show you is about graphs. We've done this a little bit already, okay? In case you don't remember or you forgot, when we graph of a distance versus time graph, and we have a line and we're trying to find the slope, what we're going to be doing is we're going to do the rise divided by the run. But if you look at the rise side of the graph, you'll notice that it is the distance that something is going. And if you look at the run side of the graph, you'll notice that it's the time that is going. And oh look, distance divided by time. What's that? That's the speed. So right here, this is where we kind of get this. This is why the slope of a distance versus time graph equals the speed of the object. Okay. So here we've got it again in this next problem. There's a line there with a slope, so we can just find the slope. Okay. All right, so let's read the question. Avery runs a distance of 20 kilometers in 3 hours at a constant speed. How fast does he travel? And we want to draw a motion diagram of his motion, okay? All right, so our solution here, so we're looking for how fast. How fast is speed? So I'm looking for V equals. Distance over time is my formula, so I write it down. Notice I didn't put any numbers in there. And so now I need to put the numbers in there. All right, so my distance, it says distance of, that's really helpful. So 20 kilometers. Sometimes it doesn't say that, it'll say goes, and then it has a distance. But if you can get familiar with the units, it's easy to pick them out. In 3 hours, okay, so 3 hours is my time. I'm gonna put that on the bottom, 3 hours. And at this point, all I need to do is the math. Okay, so I'm gonna grab my handy calculator. And I'm going to do 20 divided by 3. And I get, oh goodness, that's a lot of numbers on my calculator. Just remember, in physics class, we don't write the repeating symbol and we don't use fractions, so I'm going to round 6.67. And then the last thing I need is a unit. And conveniently, I'm going to circle it with a pencil so you can see it. It's right here, okay? I just have to write that next to it, kilometers per hour, okay? So that's Avery's speed, 6.67 kilometers per hour. I wonder if that's fast. I don't have a handle on kilometers per hour as a speed, so that makes it hard. All right, I've got a graph right here that shows how he's moving. So he's going from 0 to 20 in 3 hours, which is what it says in the problem, 0 to 20 in 3 hours. So my motion diagram, which you probably just did, actually you probably did it a while ago, starts here. All right, so I've got 3 hours. So here's Avery at 0. He starts at 0, and then he goes this way. And then my next dot, because he's moving at a constant speed, should be the same. Pretend those are the same. There's my next dot, and maybe those are the same. And so maybe my dots are an arrow apart. So maybe this is 20, and this is 0. And this is x. Okay. So there's my motion diagram. I'm just showing a constant speed for Avery. Okay. All right, let's take a look at the next example. We have a centipede traveling at a speed of 2 millimeters per second. How far does it get in 6 minutes? Okay, so I've got 2 millimeters per second and 6 minutes, and it says how far. Okay, so this is asking me for the distance, but then there's this problem here. You see how I have seconds and I have minutes right here. I can't just use the 6. That would be the number 6, right? So I need to do a little bit of math here. So how many seconds are in a minute? So I have 60 seconds in 1 minute, and I have 6 minutes. So I need 6 times 60. So I have 360 seconds. Now those match, and so now I can go ahead and do my math. Okay, so what I did there was make sure your units match. Okay? And it's just the speed in here. So millimeters and seconds, I just needed seconds there. All right, so how far? Distance. Distance equals. All right, so what was my formula for distance? There it is. Speed times time, v times t. V times t. So what I'm going to be doing is multiplying my numbers. All right, so my v is 2 millimeters per second, 2 millimeters per second. And my time is 360 seconds. Okay. And so when I multiply those together, I've already got the 360 in there, so I'm going to multiply by 2. I get 720. 720 is my answer. But what's the unit I'm going to be putting on there? All right, so it's a little harder to look at, but the seconds are going to cancel each other out. We've got a fraction here. Or you can remember that whatever's on top in the speed will be your distance. So it's that unit right here, this millimeters right there. I'm finding distance. It's on the top, so millimeters is what is the unit that goes on my answer. Okay, so that's how you would find the distance. All right, now I've got my dog Toto running at a speed of 15 kilometers per hour. That's definitely faster than Avery in the first question. She runs a distance of 3,250 meters. Oh no, here's another one that doesn't match. Okay. What you need to know is that there is 1,000 meters in a kilometer. And so what we really need to do is figure out how many thousands are in 3,250. And to do that, we're going to divide. So I'm going to divide that by 1,000. 3,250 divided by 1,000. And I get 3.25 kilometers. Okay. I don't think you'll have to do a lot of converting on the ones in the practice sheet, but if you do and you get stuck, you're not sure how to do that, you need to make sure you ask your teacher, okay? Now, I want to point out, this one says, how long will she take? A lot of students will stop there, how long, and say, oh, I'm trying to find distance. But how long will she take is different than how long. Okay, how long is a fishing pole? How long is the boat? Those are definitely distances. But when we say how long will she take, we're talking about time. So time is what we're looking for. Okay, so my formula for time, there it is. Distance divided by speed. Distance divided by speed. And my distance is this 3.25 kilometers. And my speed is the 15 kilometers per hour. Okay. Now, it's really important. Sometimes what students like to do is they like to take the bigger number and divide it by the smaller number, but you always do the top divided by bottom. Top divide bottom. Okay. So when you type it in your calculator, that's what you're going to do. I have no idea what 3.25 divided by 15 is, but I know it's less than 1 because 3.25 is a lot smaller than 15. All right, so 3.25 divided by 15. And I get a decimal. All right, so remember, I don't have a fraction here to worry about, but I'm also not gonna write all that out. I'm gonna round. So I'm gonna go 0.2, and instead of writing a 1, because there's a 6 next to it, I'm gonna round that up to a 2, okay? 0.22 is what I'm going to write down for my answer. Now I have to figure out what my unit is. So I'm looking for a time. So when I look up here and all the units that I have to work with, I have kilometers and hours and meters. I converted that to meters. So I have kilometers and hours. Okay. Which of those is my time unit? It's the one on the bottom. So my hours goes here. 0.22 of an hour. I don't know what that is. How many minutes are in an hour? There's 60. So 0.22, that's almost a quarter. So that's less than 15 minutes, I think. We can do that calculation another time. All right, now it says to draw a motion diagram, okay? Again, we're drawing a motion diagram. So we start with our little number line here, and we'll put a 0 on it. It doesn't really say which direction it is, so I'm just going to make the assumption that it's in the positive direction. And I know it's a constant motion, so I'm going to draw my dots evenly spaced. And I'm going to draw my arrows the same length each time. And so there is my motion diagram for Toto the dog. Okay. All right, if you have questions or you need more help with some of the ones on the practice sheet, make sure you ask your teacher. That's what they're there for. Thank you for watching.